a newly published scientific paper has revealed a chilling discovery about the interstellar visitor known as 3I/ATLAS. At precisely 2.1 astronomical units from the Sun, this comet suddenly began releasing hydrogen cyanide, an invisible and deadly gas. Scientists call this process outgassing. But here's the strange part. Comets don't usually hold their breath and then release toxic gas at an exact distance from the Sun. Yet Atlas did exactly that. Imagine this. You're an astronomer scanning the night sky, tracking what seems like just another icy rock passing through our solar system. Then, one morning, your data stops you cold. The object you've been monitoring for years, silent and steady, suddenly begins ejecting a massive cloud of hydrogen cyanide into space, not gradually, but all at once, as if someone had flipped a switch. This isn't rumor or speculation, it's confirmed data. On September 14th, 2025, the James Clerk Maxwell Telescope detected hydrogen cyanide emissions from 3I/ATLAS at 2.13 astronomical units from the Sun. The detection was statistically solid, over 5 sigma confidence, meaning the chances of error were less than 1 in a million. The emission rate was measured at 4.0 plus or minus 1.7 times 10 to the 25th power molecules per second. That's quadrillions upon quadrillions of cyanide molecules escaping every single second. Now, before you assume this is purely a doomsday scenario, let's clarify. Hydrogen cyanide is a natural compound often found in comets. It's the same chemical that gives some seeds their bitter almond scent. And yes, it's also the gas used in some of history's darkest moments of chemical warfare. In the human body, it blocks cells from using oxygen, causing suffocation from within even as you breathe normally. So while finding hydrogen cyanide in a comet isn't unusual, what is unusual is when and how Atlas released it. Look at the timeline. Throughout August 2025, when the comet was farther from the Sun and much colder, astronomers observed it multiple times using the same telescope and identical detection frequencies. The results came back empty. No trace of hydrogen cyanide, no signal, nothing. Then, in mid-September, as Atlas drew slightly closer, just 2.1 astronomical units away, everything changed. The same telescope, using the same methods, suddenly recorded a blazing hydrogen cyanide signature. No gradual build-up, no slow-warming trend, just an instant explosive activation. Think about that. It's like watching a dormant volcano that's shown no signs of life. No heat, no tremors, no gas, suddenly erupt without warning. Then one day, with no tremors, no warning, no signs of pressure building beneath the crust, the volcano erupts. You'd immediately wonder what caused it, wouldn't you? You'd suspect there's something deeper happening inside, a mechanism you don't yet understand. That's exactly where we are with 3I/ATLAS. Ordinary comets release gases gradually as they warm near the Sun. First water vapor, then carbon monoxide, followed by other compounds, all in a sequence tied to their melting points. But Atlas broke that rule entirely. It went from total dormancy to spewing one of the most toxic molecules known to science, hydrogen cyanide. And it did so at a distance where most comets are just beginning to stir from their icy sleep. Now consider an idea that sounds impossible until you think it through. What if ATLAS isn't a simple block of ice and rock at all? What if it's a dormant probe, built by something or someone, programmed to activate only when it reached a precise distance from the Sun? What if that hydrogen cyanide wasn't random outgassing, but a controlled emission, or even the exhaust of internal systems coming online? I know how that sounds. The instinct is to dismiss it as wild speculation, but stay with me. Over the next hour, we'll walk through a sequence of events, anomalies, and missing data points that, when connected, form a picture far stranger and far more unsettling than a natural comet. We'll look at why NASA's Psyche spacecraft mysteriously went dark during the exact time it should have captured its closest and clearest images of Atlas. We'll explore the vanishing tail incident, when the comet briefly showed an anti-tail pointing toward the Sun, an optical impossibility under known physics. We'll examine why the European Space Agency continues to withhold high-resolution spectral data from its Mars orbiters, claiming months of analysis are needed for something that should be routine, and we'll compare Atlas directly with Comet SWAN, a perfectly ordinary comet, to show just how abnormal this one truly is. By the end, you'll understand why certain researchers, quietly, off the record, are asking questions most scientists won't dare to ask in public. Questions about artificial origins, hidden motives, and whether humanity is slowly being prepared for a truth we're not yet ready to face. But before that, we need to understand what happened during the Silent Week, a period when Atlas began releasing its cyanide cloud, and at the same time, one of our most advanced spacecraft went offline. Something, or someone, clearly didn't want us to see what was happening. NASA's Psyche spacecraft, launched in October 2023, had a simple, focused mission. Travel to the metal-rich asteroid Psyche between Mars and Jupiter and study it to learn how planetary cores form. Essentially, it's a space prospector, equipped with multispectral imagers, a magnetometer, and a gamma-ray spectrometer. But here's why Psyche matters to our story. Its trajectory and sensors give it a unique ability to observe other nearby celestial bodies. It wasn't built for comet hunting, but during its cruise phase, if an object crossed its path, it could easily record it. And in early September 2025, something very special did. At that time, 3 I/ATLAS reached its closest alignment with Psyche around September 3rd and 4th. The viewing geometry was almost perfect. Bright enough, close enough, and ideally positioned for Psyche to capture detailed images, potentially even surface features and coma structures no Earth-based telescope could resolve. This was the observation window, the perfect moment. And then, something happened. This should have been the moment we received our clearest, most detailed images of 3 I/ATLAS, direct visuals from a spacecraft's perspective. But instead of pictures, we got silence. The Psyche mission maintains a public archive where its processed images are routinely uploaded, open to researchers, journalists, and enthusiasts who track its progress through deep space. Yet if you comb through that archive carefully, inspecting the timestamps and file sequences, something immediately stands out. There's a gap. From September 1st to September 7th, 2025, the record goes blank. No images, no engineering tests, no calibration frames, nothing. The spacecraft effectively went dark for an entire week, precisely when ATLAS was at its closest point. Now, before jumping to conclusions, let's acknowledge the standard explanations. Spacecraft occasionally pause operations for system maintenance, software uploads, or data relays when the deep space network antennas are redirected elsewhere. Sometimes they enter safe mode after a computer glitch, shutting down instruments until ground control resets them. And yes, data delays happen. Images taken during a specific window can take weeks to appear publicly due to calibration and verification. All of that is normal, but here's where it gets strange. NASA never explained this gap. There's no technical note, no mission log, no acknowledgement of a reset or telemetry problem. I checked official updates, mission bulletins, and public briefings. None mention this blackout. It's as though everyone connected to Psyche collectively decided that the first week of September simply didn't happen, or that what happened wasn't meant to be shared. Think about what that suggests. If the gap was truly routine, you'd expect openness. NASA could have easily said, yes, Psyche was offline for maintenance. We missed the chance to observe ATLAS, but we'll attempt new imaging soon. Instead, we got nothing. Silence about the silence. That absence of explanation points to one of two possibilities, either a level of negligence that defies reason, or the deliberate withholding of data. Data that revealed something NASA isn't ready to make public. Now look at the timing more closely. Atlas began venting hydrogen cyanide around September 14th, just 10 days after Psyche's missing data window. During that blackout week, the comet would have been near enough for Psyche's instruments to capture crystal-clear imagery. When the gap ended, ATLAS had already started its transformation. It's almost as if someone wanted to make sure there were no high-resolution photos from the crucial days leading up to the change, when the object might have begun activating. If Atlas truly isn't natural, if it contains artificial structures, mechanisms, or vents that reveal its design, those details would only be visible during close observation. Ground-based telescopes, even the most powerful ones, can only render ATLAS as a blurry speck of light. But Psyche could have changed that. It could have shown us something unmistakable. And yet, during the 1 week it could have done that, Psyche went dark. Let's entertain a possibility. Suppose Atlas began exhibiting structural anomalies in late August or early September. Suppose Psyche's cameras caught them, maybe panels unfolding, or directed gas jets firing from precise points instead of random vents. Maybe even geometric patterns inconsistent with natural rock. What would that mean? And more importantly, what would it justify hiding? Now imagine those missing images weren't lost, but flagged. Suppose automated systems or mission scientists reviewing Psyche's data realized they were looking at something extraordinary. What happens next? Would NASA immediately release those images to the public? Or would they be classified, routed through internal reviews, quietly passed to defense and intelligence agencies long before any public statement? I'm not claiming that's exactly what happened, but the timing, the missing data, and NASA's silence are all consistent with that kind of process. And that silence doesn't inspire much confidence in the innocent explanations. You'll notice this pattern again and again as we move deeper into the story. Data gaps, delayed releases, downgraded resolution where high-resolution images should exist, and ongoing analyses that take months instead of weeks. It's not a blatant cover-up, it's a soft one. A calculated control of information flow. The goal isn't to lie outright, but to manage what the public sees, how they see it, and when they see it. A slow drip of truth, carefully timed and framed, while the full picture remains out of reach. And while we're kept in the dark, ATLAS keeps moving. Its cyanide cloud expands. Its inner systems, whatever they are, continue to evolve, unseen. But Psyche's blackout was just the beginning. The next anomaly brings us to one of the oldest and simplest rules in comet science, and how Atlas seemed to break it completely. Let's talk about the tail, or more accurately, the mystery of where that tail actually went. Comets, in theory, are simple to understand, at least conceptually. You start with a nucleus, a dirty snowball made of ice, dust, and rock. As it nears the sun, solar radiation heats the surface, turning ice directly into gas. A process called sublimation. The released gas carries dust particles with it, forming a glowing coma around the nucleus. Then, the solar wind, a stream of charged particles traveling over 1 million miles per hour, blows that material outward. Sunlight adds to the push, creating a tail that always points away from the sun, regardless of the comet's direction of travel. That's basic comet physics, well understood since the 1600s. So when a comet's tail points toward the sun, you know something very strange is happening. In August 2025, the Hubble Space Telescope captured images of 3 I/ATLAS that should have shown a standard coma and tail structure. But instead, astronomers saw something bizarre, a narrow feature stretching toward the sun, not away. It was an anti-tail. Now, anti-tails aren't unheard of. They can occur when a comet's orbit aligns just right with our viewing angle, making a sheet of dust in the orbital plane appear to extend sunward, a simple trick of perspective. These are usually faint, temporary, and easy to explain once you calculate the geometry. But Atlas didn't fit the mold. Its anti-tail was too bright, too defined, and too persistent for a mere projection effect. Even after accounting for viewing angles, the geometry didn't fully make sense. Amateur astronomers observing ATLAS reported even stranger behavior. The comet's activity appeared erratic. Bursts of gas one night, then silence the next. Some nights it displayed a faint tail trailing behind it. Other nights, from the same distance to the sun, it appeared almost lifeless, a dim point of light with no coma at all. This inconsistency is deeply unusual. Once a comet begins outgassing, it typically maintains a steady baseline of activity proportional to solar heating. Atlas, however, refused to follow those rules. You wouldn't expect a comet to flicker like a faulty light bulb unless something strange is happening deep within, perhaps in its core, rotation, or inner structure. Compare that to a normal comet, like Swan, which appeared earlier in 2025. Swan was stunning. Telescopes captured its huge, glowing coma and perfect tail trailing away from the sun. Amateur astrophotographers revealed mesmerizing layers of gas and dust pulsing outward as sunlight hit fresh ice on its spinning surface. Swan behaved exactly as physics predicts: bright, consistent, and beautiful. Atlas, on the other hand, is dim, unstable, and doesn't fit the rules. If you placed their images side by side, you'd never believe they belong to the same type of object. Swan looks like a comet. Atlas looks like something trying to act like one, but not quite succeeding. So, what's behind Atlas's strange tail behavior? Let's start with the usual suspects. One possibility is fragmentation, its nucleus breaking apart, sending chunks of ice spinning off. As these pieces warm at different rates, they could cause irregular bursts of gas. Fragmentation often leads to temporary brightening, visible debris clouds, or multiple nuclei, but Atlas hasn't shown clear signs of that. Another theory is rotation. If Atlas spins with a few active vents in certain regions, its brightness could vary as those vents move in and out of sunlight. That could explain the flickering, but not the anti-tail, since jets from rotation should still be pushed away from the sun by solar wind. There's also the idea of electromagnetic forces. If Atlas is ejecting unusually charged dust, the sun's magnetic field might push material in odd directions, even temporarily reversing its flow. It's rare, but not impossible. Comets exist in electrically charged environments, where the solar wind, magnetic fields, and plasma interact chaotically. Yet even this requires Atlas to be chemically unique, producing material unlike any other known comet. And that brings us to the big question: why is Atlas so different? Here's where the speculation begins, but it's based on what we see. What if Atlas's tail isn't entirely natural? What if it involves directed emissions, gas released at specific angles, almost like nozzles generating thrust? Imagine a spacecraft using attitude thrusters. Its exhaust doesn't simply follow solar wind, it moves where the thrusters aim. If Atlas had something similar, even crude propulsion, it could produce those erratic bursts, sudden brightening, and the puzzling anti-tail that defies normal comet physics. I'm not saying this is the answer, but it explains the data better than any conventional model so far, and that's the unsettling part. If Atlas is artificial, if it's actually maneuvering, adjusting its gas emissions with intent, then it's no longer just a wandering rock from space. It's something with agency, reacting to its surroundings, releasing that massive hydrogen cyanide cloud at a time and place of its own choosing. That changes everything. Atlas stops being a fascinating mystery and becomes a potential threat. But to grasp what that threat might mean, we need to look at the people who should be investigating it and ask why they seem so reluctant to talk, which leads us to the European Space Agency and their strangely cautious handling of Atlas's Mars flyby. In early October 2025, 3I/Atlas passed within about 5 million miles of Mars, an extraordinary opportunity for close observation. The European Space Agency had two spacecraft in orbit, ExoMars Trace Gas Orbiter and Mars Express, both capable of analysing gases and imaging distant objects. ESA announced they would track Atlas, capture its spectra, and study its chemical makeup. Everything sounded like good, honest science. From Mars orbit, their instruments would get a far better view than any telescope on Earth. They carefully positioned their probes, pointed their sensors, and gathered data. Then, silence. On October 7th, ESA released the first photos. Atlas appeared as a faint dot against a starry background, taken from about 30 million kilometers away. The images were praised as a technical feat. "Look, we spotted the interstellar visitor from Mars." Proof of collaboration and progress. The press releases were upbeat but oddly vague. The pictures showed motion and a dim halo of gas, but they were blurry, almost pixelated, far below the resolution ESA usually delivers when imaging Martian terrain or moons. Some observers joked they looked like Space Invaders sprites, blocky, crude, and strangely empty of detail. More puzzling was what ESA didn't release: the spectroscopic data, the very measurements that could tell us what Atlas is made of, which gases, which isotopes, which molecular signatures reveal its origin. Instead, ESA said it would take months to analyse before the results could be shared. Months for basic spectroscopy? In principle, you point a spectrometer. collect photons, and identify lines that match known elements or compounds. It's standard work. Even with careful calibration, it shouldn't take more than a few weeks, so why delay it for so long? Perhaps because that data could reveal something ESA isn't ready to explain. Atlas already emits huge amounts of hydrogen cyanide, but what else? Could there be unfamiliar molecules or isotopic ratios unlike anything formed in our solar system? Could the readings show traces of compounds that don't occur naturally at all? Those are the answers locked in that data, and for now, ESA seems intent on keeping them sealed. By stalling the release, they keep control of the story. They make sure that when the data finally reaches the public, every word has been carefully reviewed, wrapped in cautious language designed to calm curiosity and prevent alarm. None of this outright proves a cover-up, but it perfectly fits the pattern of institutional gatekeeping. Consider how the European Space Agency has handled past discoveries. When Mars Express detected methane plumes on Mars, the data was released within weeks, igniting global debate about possible biological versus geological origins. When the Trace Gas Orbiter mapped water vapor in Mars's atmosphere, results came out quickly, fueling excitement and further research. Those findings were thrilling, but they weren't dangerous. They didn't challenge what we believe about our solar system. Atlas does. An active interstellar object emitting toxic gases near Earth's orbit is unlike anything we've ever seen. And if that object shows signs of being artificial, of not being born from natural cosmic processes, the consequences would be earth-shaking. Maybe that's why ESA is proceeding so cautiously, releasing information in slow, controlled bursts, watching how scientists and the public react before revealing more. Coordination also plays a role. ESA doesn't work in a vacuum. It shares data with NASA, other agencies, and even defense and intelligence networks. If Atlas is truly anomalous, any extraordinary findings would move far beyond ESA's scientific branch. The data would be classified, discussed in private meetings, analyzed behind closed doors. Researchers might be told to pause, to double-check, to make sure no premature statement escapes, not because of some grand conspiracy, but because institutions naturally default to caution when facing information that could spark panic or geopolitical upheaval. And make no mistake, confirmation that Atlas is artificial would change everything. It would force governments, militaries, and international agencies to answer impossible questions. Who built it? Why is it here? What's its purpose? Does it pose a threat? Are there more like it? None of these bodies are ready for those answers. So ESA keeps the real data close, releasing only harmless images and promising that the full analysis will come soon. Be patient, they say. Science takes time. Meanwhile, Atlas keeps moving closer, closer to the Sun, closer to Earth, and those with the best information stay silent. But we're not entirely blind. We can still compare Atlas's behavior with other comets and use the evidence we do have to build a case. And one of the most striking clues comes from asking a simple question. If Atlas were just a normal comet, would it act like one? That comparison is devastating. But before we get there, we need to explore a far darker idea. What if Atlas's hydrogen cyanide cloud isn't just a byproduct of chemistry? What if it's a weapon? Let's talk about poison clouds in space. It sounds absurd, like a bad sci-fi movie where aliens release toxic gas over Earth, but the physics checks out. Atlas is spewing hydrogen cyanide at roughly 4 times 10 to the 31st power molecules per second. That's a staggering figure. Collect just 1 hour's worth of that emission, and you'd have enough hydrogen cyanide gas to fill several Olympic-sized swimming pools. Over days and weeks, the total would grow into an immense cloud. But space is vast, and gas disperses quickly in a vacuum. The farther it travels, the thinner it becomes. The inverse square law ensures that doubling the distance cuts concentration to a quarter. Triple the distance, and the concentration drops to a ninth. By the time any of Atlas's hydrogen cyanide cloud reached Earth, it would be so thin that even detecting it would be difficult, let alone feeling any toxic impact. In short, the cloud itself isn't a direct danger to life on Earth. Our atmosphere is a powerful shield. Even if a dense plume somehow made its way toward us, it would burn up and break apart in the upper layers, turning into harmless atoms long before reaching the surface. To pose any real threat, a sustained and targeted release would have to occur directly in Earth's orbital path, combined with an almost impossible alignment of timing and orbital mechanics. That wouldn't happen naturally, but could it happen intentionally? That's where things become speculative, but not impossible. If Atlas is an engineered object, could it adjust its trajectory and emissions to deliver a concentrated poison cloud to a chosen target? Imagine a propulsion system built around controlled outgassing, small jets that release gas asymmetrically to generate thrust. To us on Earth, these subtle course changes might go unnoticed because we assume cometary motion is governed only by gravity. But Atlas could, in theory, maneuver with precision. By carefully adjusting its velocity, it could time its closest approach to the Sun, its perihelion, so that it crosses directly through Earth's orbital path. Then, at just the right moment, it could release a focused burst of hydrogen cyanide, not spreading equally in all directions, but vented directionally, aimed where Earth is predicted to be. From there, the cloud expands, following a calculated trajectory designed to intersect our orbit exactly when we pass through that region. Orbital mechanics meets chemical warfare. Possible? Yes, in principle. Practical? That depends on what Atlas is truly capable of, and we simply don't know. Let's break down what such engineering would require. First, propulsion. Atlas would need the ability to slightly alter its speed or heading. Controlled gas jets could achieve that, just like spacecraft that adjust orientation by venting gas in specific directions. If Atlas has internal reservoirs and controlled nozzles, minor adjustments would be easy. Second, targeting. Atlas would have to know Earth's position and orbit precisely, predicting where we'll be months in advance. That means sensors, onboard computation, and accurate orbital data, all well within the reach of any advanced civilization. Third, timing. The cyanide release would need perfect synchronization, firing exactly when the expanding cloud would intersect Earth's path. That's just orbital mathematics, nothing more. Now consider this unsettling possibility. The sudden onset of hydrogen cyanide emissions at 2.1 astronomical units might not have been random at all. It might have been a test, a systems check verifying that internal mechanisms still function after centuries of dormancy. Power up the probe, open the vents, monitor gas dispersion, and see how observers react. Watch, learn, calibrate, and wait for the optimal release window closer to the Sun. That's exactly how a reconnaissance and delivery system would behave. Built-in redundancies, diagnostic stages, fail-safes, all part of a deliberate activation sequence. If that's the case, the implications are chilling. We're not looking at a passive object that merely could pose a risk. We might be watching an active system, something self-aware in its operations, something executing a long-term plan. A machine that responds to its environment. A mechanism that might have goals, ones we don't yet understand. Think of it like a muffler on a running engine, quiet, steady, and deliberate, but undeniably alive in its purpose. If Atlas carries a hidden internal engine, something powering its movement or transmitting signals, that engine would likely produce exhaust. Hydrogen cyanide could be part of that exhaust, a chemical clue pointing to whatever machinery runs inside. Just as car fumes reveal the fuel being burned, Atlas's emissions might reveal that something mechanical is happening beneath its surface. If that engine has just powered on, if dormant systems have suddenly awakened, the sudden burst of gas fits perfectly with what we observed. It isn't proof, but it creates a logical framework, one that explains the data more cleanly than natural comet behavior. Imagine the timeline this way. Atlas enters our solar system silent, a sleeper probe conserving energy and hiding in plain sight. As it nears the Sun, internal sensors monitor distance, heat, and radiation. When it crosses a preset threshold, around 2.1 astronomical units, the activation sequence begins. Systems boot up, energy builds, and hydrogen cyanide vents into space as both a byproduct and a signal of ignition. Astronomers on Earth detect the gas and log it as an anomaly, but mainstream science dismisses it as standard cometary activity. Atlas then moves closer to the Sun, refining its path, approaching perihelion at roughly 1.36 astronomical units, a perfect point to mask further emissions under the chaos of solar heating. But if Earth happens to cross its projected debris trail, that same vented material could pose a danger we never prepared for, a threat mistaken for a natural event. To be clear, this idea rests on speculation. It assumes Atlas is artificial, capable of actions beyond what we've witnessed. Yet every conventional explanation leaves gaps: the sudden emissions, the backward-facing tail, the spacecraft communication blackouts, the data inconsistencies. When the anomalies pile up, it becomes harder to ignore the possibility we've been wrong about Atlas from the start. The hydrogen cyanide theory may sound extreme, but it matches the data uncomfortably well. And beyond that lies something even stranger: a web of conspiracies that connect Atlas's arrival to a larger, orchestrated deception. To explore that, we have to look at one of the most controversial theories ever proposed: Project Blue Beam. Part 6: Blue Beam Trigger Protocol. It's a concept so audacious that even skeptics find it hard to ignore. Project Blue Beam is said to be a secret plan by powerful global players to fake an alien invasion, using holograms, satellite projection systems, and electromagnetic illusions to scare humanity into accepting a single world government. The alleged goal? To unite the planet under centralized control by manufacturing an extraterrestrial threat. Critics call it fantasy, a blend of paranoia and sci-fi, yet among conspiracy circles, Blue Beam is treated as gospel. According to its followers, there's even a detection protocol. It starts like this. For decades, media and scientists have mocked UFOs and denied alien visitation. If that stance ever flips, if respected voices begin confirming what they once dismissed, that's the signal. It means Blue Beam is being activated, the stage is being set, the world is being prepared for something massive. The holographic systems are warming up. When the false invasion begins, people will accept it without question, because the institutions they trust will tell them it's real. It's predictive programming followed by execution, and once you know to watch for that flip, it becomes impossible to ignore when it happens. In recent years, we've seen exactly that reversal. The US government declassified multiple UFO encounters. Pentagon officials have testified before Congress about unidentified aerial phenomena. Major news outlets that once mocked alien believers now host serious discussions about strange military footage. Even NASA has launched research programs dedicated to UAPs. The entire cultural tone has shifted, from ridicule to recognition. For believers in Project Blue Beam, that's the signal. The trigger has been pulled, and now, as if on cue, an interstellar visitor appears, emitting toxic gases, behaving unlike any known comet. To them, it looks like the opening act of something larger, the test before the performance, the warm-up for a staged revelation. So let's take this hypothesis seriously for a moment. Suppose Blue Beam is real, or at least that certain powerful groups are trying to shape how humanity perceives extraterrestrial threats. In that case, Atlas is the perfect tool. It's real, visible, and trackable by both amateurs and professional observatories. It can't easily be faked, but its story can be controlled. By selectively releasing data, emphasizing certain anomalies, and withholding others, the narrative can be slowly guided. The public starts hearing, "It's just a comet," then, "It's emitting strange gases," then, "It's behaving in ways we can't explain." Step by step, people are conditioned to expect the extraordinary. By the time the event occurs, whether it's a staged holographic display or an actual contact scenario, the audience is already halfway convinced. The technology for Blue Beam may sound far-fetched, but parts of it exist today. Satellites equipped with high-power lasers could project vast atmospheric visuals. Drone formations could simulate entire fleets of spacecraft. Add electromagnetic frequency manipulation, subtly influencing brain activity or auditory perception, and you could produce mass illusions or even shared sensory experiences. Combine that with synchronized media coverage, where every major outlet pushes the same message, and reality itself becomes malleable. Whether this can happen on a global scale is uncertain, but the components are undeniably real, and this is where Atlas fits in disturbingly well. If you wanted to test public readiness for such an operation, you'd start small. You'd choose a harmless-looking interstellar object. You'd control the pace of revelations. You'd study the data flow, the social reactions, the fear metrics. Atlas becomes both the stage and the experiment, a psychological operation disguised as a celestial event. Because it's real, skeptics can't dismiss it outright. They're forced to analyze it, to debate it, to engage with the mystery. And while experts argue, the public's perception quietly shifts from disbelief to curiosity to acceptance. The line between science and spectacle blurs. The story takes hold, and the world waits for whatever comes next. Pulling off a deception of global scale would demand impossible coordination. Governments, militaries, intelligence agencies, space programs, and news networks all working in perfect unison across rival nations. It sounds absurd. Leaks would surface. Whistleblowers would talk. The sheer complexity would collapse under its own weight. Those are valid objections. But what if Bluebeam doesn't need a single secret cabal? What if it's not a master plan, but an emergent behavior? A convergence of separate interests moving in the same direction for different reasons? Imagine multiple power structures, each advancing their own agenda, securing funding, maintaining control, managing public fear, all finding the alien narrative convenient. They don't need to collaborate. The incentives do the work. Fear is profitable. Mystery is useful. And in that light, Atlas doesn't need to be a coordinated hoax. It just needs to exist. A strange, unpredictable event that each faction can spin to serve its purpose. Whether Bluebeam is real or not becomes almost irrelevant. The mechanism functions either way. Patterns form, stories merge, and reality bends toward the interests of those who benefit most. But let's step away from the political and psychological and look up, literally. Because there's another pattern emerging, one that has nothing to do with media manipulation and everything to do with the night sky itself. It's subtler, quieter, and perhaps far more unsettling. Astronomers have been whispering about it for years. Stars that once existed are gone. Beatriz Villarroel isn't a household name, but her research may hold one of the most disturbing mysteries in modern astronomy. While studying archives of old photographic plates, fragile glass negatives exposed by telescopes in the early 20th century, she began comparing them to modern digital sky surveys. Her goal was simple: find sources of light that used to exist but no longer do. She called her project VASCO, Vanishing and Appearing Sources During a Century of Observations. The results were startling. In one dataset alone, the US Naval Observatory's historic sky plates, her team identified roughly 100 light sources that appeared in the 1950s but are now missing. Not dimmer, not relocated, gone. Before jumping to alien megastructures or interdimensional theories, Villarroel's team exhausted the mundane possibilities. Old plates are notoriously tricky. Emulsions decay, cosmic rays can burn false dots, dust and chemical flaws mimic stars. They filtered those out, cross-referencing plates from different observatories and rejecting any single exposure anomalies. What remained were consistent multiplate detections, real objects that once shone in the sky but have since vanished. Mainstream explanations do exist. Some may have been short-lived flares, failed supernovae that briefly illuminated before fading into darkness. Others could be artifacts of lens reflection, extreme stellar variability, or cataloguing errors that made faint background galaxies look like stars. These cover most cases, but not all. A stubborn few resist every natural explanation. They were there, and now they're not. And that's where things start to feel wrong. Let's imagine for a moment that some of those disappearing lights weren't stars at all. Suppose they were artificial. Beacons or probes stationed somewhere in our solar neighborhood during the mid-20th century, shining steadily for reasons we still don't understand, then quietly shutting down or moving on. How would we ever tell the difference? On those old photographic plates, resolution was limited. A distant probe and a star both looked the same. Tiny points of light, fixed and constant. If an intelligent machine wanted to hide in plain sight, mimicking the glow of a background star and drifting so slowly it seemed motionless, it could do so effortlessly for decades. Then, when its mission ended or its power faded, it would simply go dark. The star disappears, and astronomers are left inventing natural explanations for something that was never natural to begin with. This idea ties disturbingly well to Atlas. If Atlas is artificial, if it's a probe sent by some non-human civilization, then it's probably not the first. No advanced species would risk interstellar exploration with just one scout. They'd send networks, fleets, a distributed web of machines covering different targets and timeframes. Some would observe passively, parked in quiet orbits, while others would move between stars, sampling, transmitting, maybe even seeding worlds. Over millennia, some would fail, others would succeed and shut down, and a few would activate only when conditions were right. To us, catching one in action would depend entirely on timing and luck. A powered-down probe could appear as a dim asteroid or star-like point until it reawakens. If even a fraction of Villarrel's vanishing stars were actually probes, it means our corner of space isn't empty, it's busy. It's alive with silent watchers, working on timescales that make human civilization look like a spark in the dark. Atlas, then, could be one of those watchers, an old machine reactivating now that our instruments are finally sharp enough to notice its quirks. And if that's the case, the hydrogen cyanide emissions we see might not be a weapon at all. They could be a signal, a communication burst meant for others like it. Think about that. We might be overhearing a conversation we can't interpret. One carried out through molecular emissions instead of radio waves, encoded in chemical signatures instead of language. To us, it looks like a poison cloud, but to another probe, scattered somewhere beyond Mars or in the outer system, it could be a clear message. I'm awake. Systems nominal, proceeding to next waypoint. The anti-tail, the odd jet patterns, the timing of the emissions, they could all be part of that code. If true, then we're not watching a threat, we're witnessing communication on a level we never expected. The reason we've missed it until now might be simple: our tools and our imagination just weren't ready. Only now, as our telescopes and sensors evolve, are we starting to glimpse that hidden layer of reality. One filled with signals, structures, and intentions moving just beyond our understanding. But that realization comes with a warning, because there's still something or someone controlling how far we're allowed to look. A barrier that decides who gets to reach into the dark and who must stay blind.